Hello and welcome. In this module, I will introduce SquidSM, an alternative to QNE ADK for quantum network application development. In this first submodule, I will recap and expand on the relationship between SquidSM and the other software packages, NetSquid, QNE ADK, and NetQASM. Then I will introduce terminology regarding the meaning of program versus application and the concept of a quantum networking processing unit, or abbreviated the QNPU. Lastly, I will spend a few words on the installation of SquidSM. But first, let us begin by answering the question, what is SquidSM? The short answer is SquidSM is a simulator for quantum internet applications written in NetQASM. But we can best expand on this answer by explaining the various things it can be used for. For example, it allows users to create their own applications and test them on a simulation. SquidSM also allows users to specify the details of the network and use this to check if their application is noise tolerant, investigate how the performance deteriorates with noise, and what the speed and latency of the application is. Mirrored to the previous usage, SquidSM also allows for the investigation of what the requirements are on the network to allow certain applications to run on the network. SquidSM is similar to QNE ADK, as both are simulators for quantum internet applications. In fact, QNE ADK uses SquidSM for its simulation, albeit a different variant. In this tutorial, we will focus on the variant of SquidSM called Stack, while QNE ADK uses a variant of SquidSM called Multi-threaded. There is a small difference in writing style for the applications in this new variant. These changes were introduced to address a shortcoming of the multi-threaded variant that affects how the time and events are handled between application and the underlying simulation. In the Stack variant, we have to use Python generators to achieve this. Thus, the application and many other objects are Python generators. Yet in practical terms, what this boils down to is that one needs to add yield from statements at the locations where the program needs to wait. We will demonstrate this in the following submodules. As the removal of these shortcomings for time and events is crucial for research, most of the following developments have focused on the Stack variant of SquidSM. As such, more features for the network simulation are available in the Stack variant, such as more models for entanglement generation, classical communication with delays, and metropolitan hubs. The NetQASM package consists of three components: the NetQASM language, the NetQASM SDK, and the NetQASM compiler that compiles the commands from the SDK into the NetQASM language. This tutorial is oriented towards using the NetQASM SDK for writing applications, as that is the recommended usage. Although users primarily use the NetQASM SDK, the SquidSM simulation simulates the execution of NetQASM language routines. As such, it is also possible to create NetQASM language routines by other means and use SquidSM to simulate those routines. SquidSM uses the NetSquid package as a simulation engine for the discrete event simulation, qubit simulation, and more. But with minor exceptions, a user of SquidSM will not interact directly with NetSquid. The SquidSM package does not provide the hardware models itself, but uses a collection of packages colloquially known as the NetSquid snippets. These packages are usually named NetSquid-something and are Python packages that heavily use NetSquid in order to provide models for specific components. Let us move on to the terminology and concepts. We maintain a specific terminology for the words program and application. We define a program as the code that runs on a single node to achieve a certain application. An application, however, is the combination of programs to run a certain application. An example of this would be the server program and the client program that make up the blind quantum computing application. In the quantum internet that Kia is building, an end node can typically be split into two components. One is the host component, that is a classical computer, and is the device running the program. It interacts with the quantum networking processing unit, the QMPU, by sending netcasm language routine to this QMPU. The QMPU is a combination of underlying quantum device combined with a classical controller. It will execute the netcasm routines that are sent to it. It is responsible for performing actions such as initializing qubits, performing local gates, generating entangled qubits, and more. An operating system that is being developed for executing the netcasm routines on hardware is QNode OS. A user writing an application using the netcasm SDK operates inside the host and interacts mostly with the classical socket, APR socket, and qubit objects. The classical socket is the endpoint for sending and receiving classical information to one other node. The EPR socket provides the ability to generate entangled qubits with a remote node. The qubit objects allow one to perform local qubit operations. The last two of these objects are abstractions provided by the netcasm SDK that make it easier to program, but only exist for the purpose of creating netcasm language routines. To install SquidAsm, a Mac OS system or Linux is required. Windows users are advised to install Windows Subsystem for Linux, WSL for short. This allows one to run an integrated Linux environment in the Windows operating system. Because SquidAsm requires NetSquid and because downloading NetSquid from the NetSquid server requires a NetSquid forum account, the recommended first step is to register to the NetSquid forum. To then install SquidAsm, we recommend consulting the installation manual. We keep the most recent installation tutorial on the SquidAsm Read the Docs page. If one runs into any installation issues, we advise visiting the Q&A forum under the SquidAsm category. One may find earlier forum posts or ask support via public post or direct message.